When the Cold War redefined global strategy in the aftermath of World War II, military planners confronted a terrifying reality. Fixed airfields across North America and Europe were suddenly recognized as vulnerable targets for nuclear attack. To preserve national strike capabilities, naval architects envisioned a mobile deterrent that required no concrete runways, operating instead from the vast expanses of the world's oceans. By coupling early turbojet propulsion with advanced hydrodynamic hulls, engineers created waterborne aircraft capable of reaching subsonic speeds while operating from remote sea anchorages. Supported by tender ships and submarines, these jet-powered flying boats offered an unpredictable dispersed striking force. This restored and colorized archival record brings new clarity to a remarkable era of aerospace design. From radical hydroski fighters to four-engine strategic nuclear bombers, these high-speed seaplanes pushed marine engineering into uncharted territory. Through rare footage, vivid restored archival film, and interviews with aviation historians, examine the structural innovations, tragic flight test failures, and intense inter-service rivalries that define the quest for ocean-based jet power. Enjoy the video.
In the 1990s, Russia stood at a crossroads. The Cold War had ended, and with it, decades of isolation. In cities like Lenchik, along the Russian Riviera of the Black Sea coast, a new sense of possibility was taking hold. For the first time in generations, the future felt uncertain, but hopeful. The tensions that once defined an era were easing, replaced by a fragile sense of openness. A nation long closed to the outside world was beginning, slowly, to reveal itself. And nowhere was that change more visible than in the skies above. MiG and Sukhoi fighter jets, long the pride of the Russian Air Force, were of course on display. But here, along the Black Sea, the setting told a different story. Maritime aviation took center stage. Amphibious and civilian aircraft began to share the spotlight, signaling a shift from pure military power. In this moment of change, aviation began to reflect a different set of priorities. Amphibian planes built for leisure and exploration appeared alongside those designed to save lives, fight fires, perform rescue. But then, the moment everyone had been waiting for. The Beriev A-40 Albatross. At the time, the most advanced seaplane Russia ever produced. A massive jet-powered flying boat designed to patrol vast stretches of ocean, far beyond the reach of traditional aircraft. Originally built for anti-submarine warfare, the A-40 was intended to track and engage enemy submarines across open seas, operating independently for long durations. Its high-mounted turbofan engines kept it clear of spray, while the hull was engineered to handle rough water landings, giving it the rare ability to transition seamlessly between sea and sky. With a wingspan rivaling that of large transport aircraft and the speed of a jet, it combined endurance, range, and flexibility in a way few aircraft had before. While the A-40 demonstrated what was possible, Beriev recognized the need for a more practical design. The focus shifted towards a smaller, more efficient amphibious aircraft, one that could serve a wide range of roles and appeal to international customers. That effort led to the Beriev BE-200. Developed as a multi-role platform, it was intended for firefighting, search and rescue, transport, and other civil applications. Its design emphasized versatility and operational flexibility, allowing it to adapt to different missions and environments. While Beriev had long defined the Russian seaplane, the West had its own legacy. In the United States, flying boats had already proven their value, linking continents, carrying passengers, and opening new routes and frontiers. One of the leaders of the seaplane industry? Glenn L. Martin. Through the golden age of aviation, Martin helped shape long-range air travel. But the golden age of the seaplane wouldn't last. As the Cold War took hold, the romance of transoceanic flight gave way to far more urgent priority: long-range strategic air power. And once again, the oceans would play a critical role. Glenn Martin's answer was the Martin P6M Sea Master, a jet-powered flying boat designed to operate far from traditional airfields, beyond the reach of a conventional first strike. By basing aircraft on open water, the Navy envisioned a force that could disperse, survive, and retaliate if needed. The Sea Master was built for speed, range, and nuclear delivery. And for a brief moment, it offered a very different vision of the future of naval air power. By the 1970s, the flying boat had all but disappeared from military service. In its place, the carrier battle group, floating cities at sea, projecting power with a full complement of aircraft. Naval aviation had evolved, leaving the seaplane behind. It's a far cry from decades earlier, when flying boats played a crucial role, one that would help shape the outcome of World War II. Aircraft like the consolidated PBY Catalina hunted enemy submarines across vast stretches of ocean, dropping depth charges against targets below. And when the mission changed, they became lifelines, rescuing downed airmen from the sea. Flying boats helped turn the tide across the Pacific, extending the Navy's reach and putting the Japanese on their heels. But in the end, the war would require something far more decisive.
3, 2, 1, now.
The atomic bomb. And with it came a new kind of power. Strategic bombers would soon be able to strike across continents, carrying weapons capable of destroying entire cities or fleets. It was the dawn of the atomic age, and it changed everything. For the U.S. Navy, it raised an unsettling question. In a world defined by nuclear weapons and long-range bombers, what role could sea power still play? The Navy's very existence was now an open question. The U.S. Air Force, newly independent now, was on the rise, building its strategy along strategic nuclear bombers. To many, they represented the future of warfare. In Washington, that vision carried weight. President Truman backed a defense strategy that prioritized the atomic mission, and with it, deep cuts to naval funding. For Navy leadership, the implications were stark. Within the Joint Chiefs, tensions between the services began to boil over. Senior admirals pushed back, warning that reliance on bombers alone was a dangerous gamble. They argued that sea power and carrier aviation remained essential, but with the Air Force's argument winning out, the aircraft carrier could become a relic of the past.
Today, science is providing us with more devastating explosives, and with intercontinental bombers capable of carrying them direct to the enemy nations from existing American bases.
At the center of the Air Force's new strategy was the Convair B-36 Peacemaker, a bomber of unprecedented size and range, designed to carry nuclear weapons across continents. To its supporters, the B-36 made traditional naval power increasingly obsolete. Why risk carrier task forces when a single bomber could deliver decisive force from half a world away? In Washington, the future of naval aviation hung in the balance. Plans for a new generation of supercarriers, including the USS United States, were abruptly canceled. The fleet was left to rely on carriers built for a different war. World War II-era ships, aging and increasingly vulnerable in the nuclear age. At the same time, strategic thinking in the Pentagon continued to favor long-range bombers over sea-based air power. the Navy's role was being questioned at the highest levels. Backed into a corner, naval planners began to look for alternatives. Aircraft carrier task forces did make for a big target, but aircraft operating from the open ocean, dispersed, mobile, and unpredictable, might survive. The idea took shape: a seaplane striking force, a fleet not tied to decks or runways, but to anywhere there was water. And with the jet age dawning, the U.S. Navy looked across the pond for inspiration. In Britain, aviation history was about to be made. British aircraft builder Saunders-Roe set out to answer a fundamental question: could a high-performance fighter operate directly from the sea? The result was the Saunders-Roe SR.A1, a bold attempt to merge jet propulsion with the flexibility of a flying boat. Designed at a time when runways were seen as vulnerable targets, the concept offered something different: a fighter that could disperse across open water, far from fixed bases. It was an idea shaped by the same pressures facing navies around the world: survival through mobility. But performance would be critical. To compete with land-based jets, drag had to be minimized wherever possible. Saunders-Roe addressed this with retractable pontoons, letting it shed the bulk of the water-handling gear once airborne, streamlining the aircraft for higher speed and efficiency. When it finally took to the air in 1947, the SR.A1 took the seaplane into the jet age. In the air, the concept proved itself. The aircraft demonstrated that a jet-powered flying boat could achieve capable fighter performance, combining speed, stability, and control in a way few had thought possible. Powered by twin turbojet engines, it reached a top speed of 520 miles an hour, placing it firmly in the performance class of early jet fighters. For the time, it was breaking new ground, and on the other side of the Atlantic, the U.S. Navy was paying close attention. In the United States, the idea took on a more radical form. Convair's answer was the F2Y Sea Dart, a jet fighter designed to operate directly from the open ocean. Unlike traditional flying boats, the Sea Dart used a pair of retractable hydroskis, allowing it to lift clear off the water at high speed, reducing drag during takeoff. The goal was ambitious: a supersonic fighter, free from runways, capable of dispersing across vast ocean areas, making it far less vulnerable to attack. Powered by twin turbojet engines, the Sea Dart was designed to exceed the speed of sound, and in testing it came close. But operating a jet from water introduced some serious challenges. At lower speeds, the skis generated intense vibration, making takeoff rough and difficult to control. The Navy explored a range of deployment concepts, including even launching them from submarines. Despite its promise, the Sea Dart never fully overcame its technical challenges. While the Navy's pursuit of seaplane fighters began to fade, the need for large multi-purpose flying boats remained. Aircraft that had proven their value in World War II, long-range patrols, anti-submarine warfare, search and rescue. Within the Bureau of Naval Weapons, naval planners focused on what worked. Not speed for its own sake, but endurance, versatility, and the ability to operate far from fixed bases. The ocean itself remained a strategic advantage. That thinking gave rise to a new generation of flying boats, including the Martin P6M Marlin. Designed for long-range maritime patrol and anti-submarine warfare, the Marlin carried forward the lessons of the past, while adapting to the demands of a new era. By this point, the Glenn L. Martin Company had firmly established itself as a leader in flying boat design. From its facilities outside Baltimore, the company had spent decades refining aircraft built not just to fly, but to operate from the sea. That legacy reached back to the golden age of aviation, when Martin aircraft helped open the world's oceans to air travel. Introduced by Glenn Martin himself, the Martin M130 China Clipper became a symbol of that era, carrying passengers across the Pacific in a way never before possible. It was a time when flying boats represented the future. That vision of large ocean-going aircraft continued into the wartime years. At Martin, the flying boat had grown in both size and ambition. In a traditional ceremony, Glenn Martin looked on as the aircraft was christened, marking the arrival of a new class of seaplane, the Martin JRM Mars, one of the largest flying boats ever built, designed to carry massive loads across vast oceans. It reflected the strategic demands of a global war. As it slipped into the water, the scale became clear. This was no longer just an aircraft, but a true ocean-going transport. But for Martin's next big flying boat project, inspiration would come from something much smaller. In the late 40s, the Navy modified a Grumman JF-4 Widgeon to test innovative new hull designs. What was learned would help shape one of the most ambitious flying boats ever produced. From the factory floor in Maryland, a new kind of aircraft emerged. The Martin P6M Sea Master, a jet-powered flying boat designed not for patrol, but for nuclear strike. At over 130 feet in length and a wingspan of 102 feet, the Sea Master matched the scale of contemporary land-based bombers. But its approach to the mission was entirely different. Built to operate far from traditional infrastructure, it offered a level of flexibility that conventional aircraft could not. Even its shape reflected that purpose.
It was designed with what is called anhedral in the wing. An anhedral, instead of the wings being, if you will, angled upward, when you're looking at the airplane from the front, the wings were actually angled down. And in so doing, it was possible to just mount floats permanently on the tips of the P6M's wings. And those floats, when the airplane sat in the water, those floats stabilized the airplane from wingtip to wingtip.
Power came from 4 turbojet engines mounted high above the wing. This unusual placement was deliberate. By lifting the engines clear of the spray, designers avoided the risk of water ingestion during takeoff and landing. Early versions used Allison J71 engines, later replaced by more powerful Pratt & Whitney J75s, which would give the aircraft a top speed approaching 600 miles an hour. But integrating jet engines into a flying boat was no small feat. The structure had to withstand saltwater corrosion, vibration, and the stresses of high-speed orientation, all while maintaining the integrity of a watertight hull. It is a complex balance of marine engineering and high-performance aviation. Operating from sea required an entirely different kind of ground system. Instead of landing gear, the Sea Master used a detachable beaching system, a wheeled dolly with stabilizing floats that allowed the aircraft to move between land and water. Once afloat, the aircraft was completely independent, free to taxi, take off, and recover without the need for a runway. The system was central to the Navy's vision. A dispersed force operating from remote anchorages, supported by tenders rather than airfields. In theory, it made the aircraft harder to locate and destroy. Before it could ever fulfill its mission, the Sea Master had to prove it could survive its most demanding environment, the water. Testing began with the first prototype, the XP6M1, here on the waters of the Chesapeake Bay. At low speeds, the aircraft behaved like any other flying boat. But as power increased, the dynamics changed rapidly. The hull began to rise transitioning from displacement to planing, skimming across the surface as drag fell away. This was the critical phase, where hydrodynamics and aerodynamics had to work together perfectly. With 4 jet engines producing immense thrust, the margins were thin. Instability in control could be compromised in an instant. Run after run, speed increased. Each pass pushing the aircraft closer to flight. Then, on July 14, 1955, the XP6M1 finally crossed that threshold. Lifting cleanly from the surface, transitioning from waterborne machine to high-speed jet aircraft. In the air, the Sea Master revealed its true character. Fast, stable, and capable of low-level flight at speeds approaching 600 miles an hour. It was a remarkable achievement, a jet-powered flying boat that could operate at speeds and altitudes once reserved for land-based bombers. For the Navy, it was proof that their concept could come to life. The Sea Master was designed for one purpose above all else: strategic nuclear strike. But by the mid-1950s, the Air Force was well ahead in that mission. Aircraft like the B-47 Stratojet were entering service in growing numbers. Faster, higher flying, and capable of delivering nuclear weapons across vast distances. With each new deployment, the pressure on the Navy increased. Strategic bombing was becoming the dominant doctrine of the era, and the Air Force seemed firmly in control of it. For the Navy, the Sea Master represented a way back into that mission, a way to stay relevant, a platform capable of delivering a nuclear payload at high speeds while operating in ways that differed from traditional bomber forces.
It was effectively nuclear capable, and it would have been able to deliver nuclear bombs over great ranges and effectively operate from any place on the globe, which the U.S. Air Force could not claim.
Not everybody welcomed the idea. For the Air Force, strategic bombing was its domain. Air Force leaders like Curtis LeMay saw the Navy's efforts as an intrusion. The Sea Master was more than a Navy dream. It was a challenge to Air Force doctrine, budgets, and control of the nuclear battlespace. Undaunted, in the air, the Sea Master continued to demonstrate its capabilities. It was fast, approaching 600 miles an hour, and optimized for low-level flight, where speed and altitude could reduce exposure to enemy defenses and radar. Its internal bomb bay allowed it to carry a nuclear payload cleanly, and during testing, those systems performed as intended, doors opening smoothly, even at speed. This aircraft was just the first prototype to be made, a proof of concept designed to validate an entirely new way of operating high-speed aircraft from the sea. During its initial flights, the second prototype was already taking shape, incorporating lessons learned. Beyond that, the plans were far more ambitious. The Navy envisioned full-scale production, with operational aircraft entering service in the years ahead. Entire squadrons built around the Sea Master, trained, equipped, and ready to carry out the strategic mission. But achieving that mission required advanced and sometimes unconventional design solutions. Among them was the aircraft's distinctive T-tail. Mounted high above the fuselage, it featured an all-moving horizontal stabilizer, giving the aircraft greater control authority at high speeds. It was an innovative system, but also a demanding one. The forces involved were significant, and the margin for error was small. Just as the program was beginning to show real promise, a fatal flaw hidden deep within that control system, was about to rear its ugly head.
They unfortunately made the discovery that there had been a misdesign effectively in the hydraulic actuators for the horizontal tails of the P6M. And there was a failure that was built into the system, and unfortunately that failure occurred on 2 of the test flights of the aircraft.
On December 7th, 1955, a crew was conducting a test flight over the Potomac River in southern Maryland. Everything was going smoothly. The Sea Master's all-moving tail means that the entire horizontal surfaces at the tail can move up and down. Tilting up pushes the aircraft down, pushing down pulls the airplane up. Up till now, the system had worked. But now a design glitch caused the horizontal surface to abruptly go up without pilot input.
This occurred in a very, very short period of time. We're talking a matter of a half to 3/4 of a second. And in the event of that occurrence, the aircraft was structurally overloaded and basically disintegrated, came apart in flight.
The Sea Master was subjected to 9 Gs of stress as it began an outside loop. The crew never had a chance. It disintegrated at 5,000 feet and crashed into the Potomac River. None of the 4 crew members survived. It would be almost a full year before the second prototype took to the air. But once again, one of the aircraft's most advanced systems would also prove to be its most vulnerable. During a test flight over Delaware in November 1956, the aircraft climbed to an altitude approaching 21,000 feet. Then, without warning, a glitch in that tail control system, a malfunction in the stabilator mechanism, locked the tail into position, leaving the crew unable to control the aircraft's pitch. The nose rose sharply, and the aircraft stopped responding to inputs. With no way to recover, the crew made the decision to abandon the aircraft. This time, all 4 successfully ejected. Moments later, the Sea Master broke apart in midair, spreading debris across Delaware farmland. The loss confirmed what engineers feared. The problem wasn't isolated. Despite the losses, the program moved forward. In Washington, support remained, driven by the belief that the concept was still sound, even if the execution could use a little refinement. Funding continued, and work resumed at the Glenn L. Martin plant outside of Baltimore. Engineers turned their focus to the root causes of the failures, redesigning the tail control system, strengthening key structural components, and improving overall stability at high speed. The result was the pre-production version, the YP6M1. The Navy had moved on from experimental to pre-production, built to get everything dialed in before full operational versions were built. Glitches in the tail control system were weeded out, and there was improved integration across the airframe. The first pre-production YP6M was completed about a year after the second prototype crash. Testing resumed in January 1958. 5 more would be ordered, each aircraft representing a step towards something larger. Once again, the first step, getting the aircraft into the water. The pre-production models handled better. The control issues that had plagued the first 2 prototypes were addressed. And once again, the Sea Master was back at it, this time with a clearer path forward. With the YP6M1 now in testing, the program moved beyond development and into simulated operations. At Harvey Point, North Carolina, the Navy began evaluating how the Sea Master would function as part of a forward strategic force. Weapons integration was a critical step. Dummy ordnance was loaded through the top of the fuselage, feeding into the aircraft's unique rotating bomb bay. Rather than opening directly into the airstream, the cylindrical bay would rotate into position, allowing weapons to be deployed cleanly at high speeds while minimizing drag and structural stress. It was a solution designed for a very specific mission, but the Sea Master itself was only part of the network. In one concept, submarines would act as forward support units, refueling and rearming the aircraft far from established bases. By moving the assets closer to the Soviet Union, the Navy predicted that the Sea Master could be positioned within striking distance of nearly any target across the vast country. It was the ambitious strategy, combining sea-based stealth with airborne strike capability. In the air, the Sea Master continued to demonstrate its potential. Fast, capable, and increasingly refined with each test. But not everything was going swimmingly. Even in these later trials, a persistent issue remained. At certain speeds, the aircraft could begin to oscillate along the water surface, a condition known as porpoising. Left unchecked, it could affect stability during takeoff and landing. It was becoming a problem that would require further redesign. Despite the issues, the Navy wasn't quite ready to walk away from the Sea Master. Instead, they worked with Congress to approve funding for an improved version of the aircraft. The result? The P6M2. One of the first priorities, the cockpit, where workload and visibility had to be improved. Systems were reorganized, controls refined, making the aircraft easier to manage during the demanding phases of water operations and low-level flight. One of the most visible upgrades was the cockpit canopy, redesigned for improved visibility. But the most significant changes involved the power plant. The earlier Allison J-71s were replaced with more powerful Pratt & Whitney J-75 turbojets, each producing over 17,000 pounds of thrust. The new installation was cleaner and more efficient, with the exhausts aligned rather than staggered, improving airflow and reducing interference with the airframe. The result was a heavier but more capable aircraft, with greater payload, improved performance, and speed approaching Mach 0.9 at low altitude. With the P6M2, the Sea Master had finally become the aircraft the Navy had been chasing from the start. The P6M2 could reach about 630 miles an hour, climb to 40,000 feet, and carry its mission over roughly 2,000 miles. It was a large aircraft by any standard, 134 feet long, with a wingspan just under 103 and a wing area of 1,900 square feet. And production and planning envisioned rough water takeoffs at close to 190,000 pounds. The structure was built for that kind of punishment. At the wing roots, the skin was more than an inch thick, part of what allowed the Sea Master to survive prolonged low-level flight at high speed. Contemporary accounts noted that few aircraft of the era could match its on-the-deck performance. It also received an aerial refueling probe, and Martin even developed a probe and drogue kit that could convert the aircraft into a tanker. The unique rotating watertight bomb bay built into the hull could carry up to 30,000 pounds of mines, bombs, or reconnaissance stores. And tests proved the aircraft could release stores at around 500 miles an hour. But just as the Sea Master was coming into its own, the Air Force was raising the stakes yet again. The B-47 was being replaced by the B-52, giving Strategic Air Command an even more formidable, long-range nuclear bomber.
One of the attributes of the P6M over the B-52 was that basically it could set up a base anywhere in the world. The B-52 couldn't make that claim. The B-52 was such a large airplane, it took very specialized air bases to accommodate it, very specialized runways capable of supporting a lot of weight, runways that were very long. One of the big Navy arguments was that all they really needed was a ship positioned somewhere on the, on one of the world's oceans that had a refueling capability specifically for the P6M, and that in effect could become the P6M's base wherever it operated on the face of the Earth. And that was a pretty strong argument.
The Sea Master brought a new capability to the table, flexible, mobile, and built around naval operations. Operated from the sea, supported by tenders, positioned where it was needed most. But the Boeing B-52 offered scale, with intercontinental range and massive payloads backed by an expanding global infrastructure. The mission was the same, but the methods could not have been more different. And behind the scenes, the rivalry was only growing more intense.
The Air Force was not blind to what the Navy was doing with the P6M, and they were not blind to the fact that the P6M basically had the same capabilities that early models of the B-52 and late models of the B-47 had. And I think, and this is just my opinion, I've never seen anything on paper to verify this, but I propose to you that the Air Force and its constituency in Congress, if nothing else, sped up the decision to kill the P6M.
In Washington, concerns were growing. The Sea Master program was ambitious, but increasingly expensive. As costs rose, so did questions about its long-term value. At the same time, another reality was becoming clear. Earlier predictions of the aircraft carrier's decline had proven premature. In Korea, carrier-based aviation had once again demonstrated its importance, delivering sustained air power without relying on forward bases. The Korean War had been a wake-up call, and by the mid-50s, a new generation of carriers was entering service. Larger, more capable, and better suited to the jet age. The Navy's focus began to shift. In 1957, the Bureau of Aeronautics issued a requirement for an all-weather attack platform capable of long-range interdiction. The end result would be the Grumman A-6 Intruder. Designed to operate from carriers day or night in any weather, it would go on to become one of the Navy's most reliable and effective strike aircraft. But the Navy also had another program that wouldn't help the Sea Master's case. By the late 50s, they were moving forward with a carrier-based nuclear supersonic strike aircraft, the North American A-5 Vigilante. The Vigilante could deliver a nuclear payload at speeds approaching Mach 2, a dramatic leap in capability over earlier aircraft. But the nail in the coffin for the Sea Master program came not from the air, but from beneath the sea. By the late 50s, the U.S. Navy was developing the UGM-27 Polaris. For the first time, the Navy could deliver a nuclear strike from a platform that was virtually undetectable. There was no need for runways, no need for tenders or recovery. The mission the Sea Master had been built for could now be accomplished more effectively and more reliably from below. Almost overnight, the strategic logic behind the Sea Master disappeared. By August 1959, the decision was made to cancel the Sea Master program. In total, 12 aircraft had been built, including prototypes and pre-production models. Martin made one final attempt to carry the concept forward, proposing a civilian version known as the Sea Mistress. But there were no takers. Soon after, the Glenn Martin Company left the aircraft business entirely, shifting to missiles and electronics. The Sea Master would be Glenn Martin's final aircraft.
All the airplanes were indeed scrapped, and to this day, I think a number of naval aviation historians and, of course, enthusiasts regret that because no P6M exists on the face of the Earth. They're all gone.
While the Americans abandoned the idea, the Soviet Union continued to pursue the concept. Behind the Iron Curtain, interest in jet-powered flying boats continued, with Western designs like the Sea Master offering a glimpse of what might be possible. Headquartered in Taganrog, Russia, On the northern shore of the Sea of Azov, the Beriev Design Bureau was uniquely positioned to specialize on one thing: flying boats. The focus would make Beriev the center of Soviet amphibious aircraft development. While others moved on, the concept here was refined, tested, and pushed forward. Behind it all was its founder, Georgy Beriev. His early successes with planes like the Beriev BE-6 provided a strong foundation for taking the flying boat into the jet age. And that was ultimately manifested in the Beriev R-1, the Soviet Union's first jet-powered flying boat. First flown in 1952, it was a bold leap forward. It would never enter service, but what Beriev learned here would pave the way for the next step. What emerged from the Beriev factory was far more refined. The Beriev BE-10, sleeker, faster, and more capable than the R-1, it brought jet-powered maritime aviation closer to operational reality. With swept wings, powerful turbojets, and a hull designed for open water performance, the BE-10 bore a striking resemblance to Martin's P6M Sea Master.
And the BE-10 in 1964 made major headlines throughout the world. It was the world's first successful, if you will, jet-propelled flying boat to enter operational service. In many respects, it superficially resembled the P6M Sea Master.
Behind that striking design, though, challenges of operating at high-speed jet from open water had never fully been taken care of. The BE-10 pushed the limits of what a flying boat could be, setting speed records and proving that jet performance at sea was possible. But it remained a demanding aircraft to both fly and maintain. In the end, its service life would be brief. But the lessons learned, from hydrodynamics to high-speed handling, carried forward, shaping the next generation of amphibious design, both in the Soviet Union and beyond.
It was not a particularly successful airplane for basically the same reasons that many other flying boats had proved to be unsuccessful. But regardless, it was a major step in the direction of an operational jet-propelled flying boat.
The Soviet Union was also home to one of the most ambitious flying boat concepts ever attempted, the Bartini-Beriev VVA-14. Behind it, Robert Bartini, one of the most imaginative minds in Soviet aviation. It was a machine designed to do everything: take off from land or sea, fly at altitude, or skim just above the waves using ground effect. It was part aircraft, part seaplane, and part something else entirely. Built to hunt American Polaris submarines, the VVA-14 was intended to combine speed, range, and flexibility in a single platform. And remarkably, it worked, at least in part. The prototypes flew conventionally, proving core aerodynamics. The aircraft could operate from runways and then transition to the water. But the full version, vertical takeoff, ground effect flight, and other advanced systems never came together. In the end, only a handful were built. But for a moment, it showed just how far the idea of a flying boat could be pushed. Meanwhile, the Beriev Design Bureau continued to find success with more conventional designs. The next of these was the Beriev BE-12, which first flew in 1960, just as the jet age was reshaping naval aviation. Powered by turboprop engines and built for endurance, the BE-12 became a mainstay of Soviet maritime patrol. Adapted for search and rescue, it could land in open water and recover crews in distress. And in later years, that same versatility saw it take on a new role in battling wildfires from above. But the Beriev Design Bureau had never given up on the idea of the jet-powered flying boat. With decades of experience, the vision continued to evolve, refined, tested in scale, and shaped on the factory floor. By the mid-'80s, the legacy of the early jet-flying boats from the 1950s would take on a new shape. Born again as the Beriev A-40 Albatross. First flown in 1986, the A-40 was designed as the next-generation anti-submarine aircraft. It was capable of operating from both open ocean and conventional runways. It was larger, faster, and more capable than anything Beriev had built before, represented a culmination of decades of work, bringing jet performance and true amphibious flexibility together in a single aircraft. Born in the secrecy of the Cold War, the A-40 remained largely hidden from view. But by 1990, as the barriers between East and West began to fall, that secrecy wouldn't last for long. With the Cold War in the rearview mirror, a different scene begins to take shape. Along the shores of the Black Sea, crowds gather, drawn by the sound of jet engines and the promise of something new. Aircraft sweep overhead, and for a moment, the divisions of the past feel like a distant memory. The former Soviet Union begins to open its doors, offering a rare glimpse into decades of closely guarded aviation development. And here, in the open air, what was once hidden is finally brought into the light. Westerners were wowed by the vertical lift of the Yak-38. But the star of the show was sitting on the other side of the airfield. Beriev's bold flying boat, the A-40 Albatross. It's an aircraft unlike anything that's graced an air show ever. By the 1990s, Beriev was already envisioning a family of aircraft, a search and rescue version, the A-42, and a maritime patrol variant, the A-44. But with the end of the Cold War, new opportunities emerged. Civilian variants, passenger versions, cargo transports, concept that could carry over 100 people, turning a Cold War military machine into something the world could use. By 1998, the Beriev A-40 had set over 140 world records. Quiet proof of what it was capable of. It was a glimpse of the future, but also the past. A legacy dating back to early Soviet jet seaplanes and Glenn L. Martin's Sea Master. Speaking of the past, the Beriev BE-12 was on hand. In the sign of the changing times, Beriev showcased its BE-12 looking for international sales, where it found success, fighting fires, saving forests, proving its value in a different kind of mission. The A-40 joins it, old and new flying together, but unmistakably born from the same lineage. In another era, these machines were built for conflict, shaped in secrecy and measured in silence. But here in the open air, their purpose feels different. Not just symbols of power, but of possibility.
Thanks for watching this video. For more deep dives and rare and restored historical archival footage, please like it, and if you can, subscribe to our Dronescapes channel to help us grow it together.